As in the previous question, we need to determine the direction that each one of the three forces tend to turn the system about the pivot. This is the pivot. It is the turning point. It is the point about which the system turns. Now let's start with the 2.5 Newton force. So we assume F2 and the 10 Newton force are not there. In what direction will the 2.5 Newton force turn the system? It will turn the system in the anti-clockwise direction. Similarly, for F2, we assume 2.5 Newton and the 10 Newton force are not there. Again, in which direction will F2 tend to turn the system? Which direction is that? Anti-clockwise. We notice something strange here. The 2.5 Newton force and F2 turn the system in the anti-clockwise direction, although the two forces are on opposite sides of the pivot. Previously, we saw that the two forces which turned the system in the anti-clockwise direction or in the same direction were on the same side of the pivot. In this question, we have two forces which are on opposite sides of the pivot, but they turn the system in the same direction. So the 2.5 Newton force and F2 turn the system in the same direction, which is anti-clockwise. How about the 10 Newton force? Again, we assume the 2.5 Newton force and F2 are not there, and the 10 Newton force will turn the system clockwise about the pivot. This system is in equilibrium, so we apply the principle of moments. The principle of moment states that the sum of the anti-clockwise moments about point O is equal to the sum of the clockwise moments about the same point. So as in our previous question, this is the turning point. This is the point about which the system turns. So the 2.5 Newton force tends to turn the system anti-clockwise, and F2 anti-clockwise. 10 Newton force clockwise. So we start by calculating the moment due to the 2.5 Newton force about point O, and it will be 2.5 times 0.06. Remember, this is the distance from the turning point, which makes 90 degrees, or which is perpendicular to the line of action of the 2.5 Newton force. So we have 2.5 times 0.06. That one we add to F2 times 0.05, and this gives us 10 times 0.12. This gives us 0.15 plus 0.05 F2 is equals to 1.2. We take 0.15 to the other side. We remain with the 0.05 F2 is equals to 1.20 minus 0.15, which gives us 1.05. So we have 0.05 F2 is equals to 1.05. In order to get F2, we divide both sides by 0.05. 0.05. This one cancels out with that. This one gives us 21. And F2 is equals to 21 newtons. Again, it is just as simple as that. The only trick with this question is that F2 and the 2.5 Newton force, although they are on opposite sides of the pivot, they tend to turn the system in the same direction. That is the only trick in this question. Everything else is the same as the previous question. Another point we might want to note in this question is that we can have two forces on the same side of the pivot, but they turn the system in different directions. F2 and the 10 Newton force are on the same side of the pivot, but F2 turns the system anti-clockwise while the 10 Newton force turns the system clockwise. Two forces on the same side of the pivot, but they turn the system in different directions. The previous point was two forces on opposite sides of the pivot, but they turn the system in the same direction. Now we are saying we have two forces on the same side of the pivot, but turn the system in different directions. These 2 points are so important, so you should note them down carefully.